Hello, so this video is meant to be a quick review of exponent properties. So let's get right to it. So if we have something like a to the third power times a to the second power, that's just, and let me use some colors here to help us differentiate here, that's just a times a times a times a times a. So here's my a squared, and here's my a cubed. So how many total a's do we have? Well, we have 5. So this is equal to a to the 5th. So this rule says that if you've got two numbers of the same base, and this only works if the base is the same, so I'll write this using a, n, and m. So a to the n times a to the m, that's equal to a to the n plus m. In other words, I can't write today. In other words, you can just add the exponents if the bases are the same. Just add them up. All right, that's 1. That's the addition property it's often referred to. Or rather, I think it's the multiplication property in which you add the exponents. And what about this situation? Well, this is equal to a times a times a times a times a, or a to the 5th, over a times a times a. And we know that we can cancel these things out. So a divided by a is 1. A divided by a is 1, a divided by a is 1, so we're left with a to the 2nd. And so this property is a to the n over a to the m is just a to the n minus m. You can subtract. Let's look at another property. With this one, I'm actually going to start by stating it. So a to the negative n power is the same thing as 1 over a to the positive n. Let's use the quotient property that we just looked at, the division, to maybe understand this. So if I have a to the 3rd over a to the, let's go 5th, so a to the 5th. Let me write that just a little bit better. So a to the 3rd divided by a to the 5th. That's the same thing as a times a times a over 5a's. Did I get it? Yep. We'll cross these out because they go to 1. So we're left with 1 over a squared. Well, what's 3? Because we learned what we could subtract. What's 3 minus 5? Well, if we were to do that, that's a to the negative 2. So this means this must also equal a to the negative 2, but it also equals 1 over a to the 2nd power. So this is just a demonstration to show why this property works. Let me give you one more demonstration. So again, we're talking about why does this property seem to work? Well, let's use some numbers. So we know 3 cubed, we'll start out with that, is 27. We know 3 squared is 9. We're going to just look at this with a pattern. 3 to the 1st is 3, and let's stop there. So how do we get from 27 to 9? Well, we divided by 3, and from 9 to 3, well, we divided by 3. So it makes sense that we would keep doing this pattern, right? We would keep dividing by 3 as we go down. And so this is moving down and going up. We're multiplying by 3. So 3 times 3 is 9, and 9 times 3 is 27. So what's 3 divided by 3? Because I have a 3 here divided by 3. Well, that's just 1. So that means 3 to the 0 power is 1. Well, so what's 3 to the negative 1 power then? Well, that's 1 divided by 3, or 1/3. So what would be 3 to the 2nd power? Well, that'd be 1/3 divided by 3, or 1/9, which is the same thing as 1 over 3 squared. So there's that power property right there. And then this also brings up a good one. Any number to the 0 power is 1, because anything divided by itself is 1. And I think this highlights why. Anything to the 0 power is 1. Okay, so now we have to remember how to apply these. So aside from, you being given problems like 5 to the 7th times 5 to the 8th, and you sit there and you go, okay, that's 5 to the 15th, right? You can add them. Aside from doing all that, how can we combine these properties together? Well, before we do, there's really one more I wanted to talk about, and that's when you've got a power to a power. So if I've got 3a squared y to the 2nd, all to the 3rd power, that's 3 of these whole things being multiplied by themselves. And I'll go down here, times 3a squared y squared. So this times this times this, all the a's being multiplied together and all the y's. It's really this thing times itself 3 times, or twice times itself. So that's equal to 27 because we know 3 times 3 times 3 is 27. And that must be a to the 6th because we can just add them up. That's a squared times a squared times a squared. And that must be y to the 6th. So you might notice that if we just were to say then that that was 3 to the 3rd times a to the 2nd times 3 times y to the 2nd times 3. So if we were just to multiply this 3 by each exponent inside the parentheses, it would get us the exact same answer. So to summarize this property, if you've got something like a to the n all to the m, that's just a to the n times m. So now let's work on applying this. What if I've got something that looks like this? Let's go with 2x to the negative 3, y to the 4th, all divided by 8x to the 4th, y to the 7th. Well, I would start out by using the quotient property and simplifying the fraction part. So I know 2/8 is the same thing as 1/4, so I'm going to start out there. But because of the quotient property, I'm allowed to subtract in division. So x to the negative 3rd over x to the 4th is the same thing as x to the negative 3 minus 4, or x to the negative 7. So I'm going to write x to the negative 7. And then same with the y's. 4 minus 7 is y to the negative 3rd. But I'm not quite done yet. Number one, I don't really need to show this 1. And I know that anything to the negative power is just 1 over that thing. And we like to write our exponents positively. So I just said I didn't need the 1, but I'm actually going to need it back because we're going to move these to the denominator. Because x to the negative 7 is the same thing as 1 over x to the 7th. And y to the negative 3rd is the same thing as 1 over y to the 3rd. And I already had that 4 down there. So this whole thing simplifies into 1 over 4x to the 7th, y to the 3rd. So when you're simplifying exponents, when you're trying to simplify them, what you're trying to do is combine all the variables. So if I've got 2 x's, I got to combine them. If I've got 2 y's, I got to combine them. And then leave it in such a way that nothing is negative. So it's not anything to a negative power. Let's do one more. So what if I have something like 3 a to the 5th, y to the 7th, all to the negative 2 power? Well, there's all kinds of properties we could use here. We want to remember that a to the negative n is the same thing as 1 over a to the n, where in this case, this whole thing here could be thought of as a as the base. So let me get rid of that, though. I don't want it to confuse us. It's not divided by a. So that whole thing there could be thought of as a in terms of this property. So this is the same thing as 1 over 3 a to the 5th, y to the 7th, squared, which is the same thing as 9 a to the 10th, y to the 14th, because I've multiplied each power by the 2. All right, let's look at one more. Okay, and I want to remind the viewers here, this is a complete and total review. So everyone who's watching this should have really already learned this rather well. This is not meant to teach for the first time at all. So what if we have a situation where things are already simplified in the sense that there's no x's or y's to combine, but they're negative? How are we going to get them to become positive? Well, we know that x to the negative 3rd is 1 over x cubed. So I'm just going to move that down. So that's y, and by the way, I don't have to mess with the y, it's already positive. Y to the x cubed in the denominator, z to the negative 5th. Well, how can I get z to the negative 5th to be positive? Well, just moving it to the numerator will do it. And I'll talk about y now. So y times z to the 5th over x cubed is equivalent to this right here, and it's considered simplified because all of the exponents are positive. But why? Why did that work? Why, if you have something negative in the denominator, like y over x cubed, z to the negative 5th, is it okay just to move that whole thing to the numerator and make it positive? Well, remember, z to the negative 5th is the same thing as 1 over z to the 5th, right? So if I'm dividing by 1 over z to the 5th, that's the same thing as multiplying by the reciprocal. And what's the reciprocal of 1 over z to the 5th? Well, that's just z to the 5th. So when I multiply by z to the 5th, to actually divide by, let me make this a bit clearer by showing it. I don't know if I explained that quite well enough, so give me another chance here. How shall I say this is y divided by all this stuff, right? Well, this is y divided by an x cubed, that's nice, but this is y divided by a 1 divided by a z to the 5th. So if this was to be rewritten, it could be looked as like y over x cubed times 1 over z to the 5th. So I have like a fraction in my denominator, and one way to get rid of that is to multiply by the reciprocal. That's why we it's the same concept that allows us to divide fractions, multiplying by the reciprocal. And so when you do that, it just gets moved to the top when you flip it over and multiply by z to the 5th. Because when you do that, and whatever you do to the numerator, you have to do to the denominator. And whatever you do to the denominator, you have to do to the numerator. So when I multiply this by z to the 5th over 1, these cancel and go away. But I have to also do multiplication z to the 5th in the numerator. So I get y z to the 5th over that remaining x cubed. And I guess that might be a brief explanation as to why that works. But the quick way to do it is just to know, okay, if it's a negative exponent, you just got to move it from numerator to denominator or denominator to numerator. And in classes, in your math learning, you should really try to take a hold of why that works. All right, thanks, guys.